Hi hello everyone, this is Akshita KN from Sri Venkateshwara College of Engineering, pursuing first year, Department of Basic Science. OD section. Today I am going to explain you about applications of polar coordinates. In this video, today I am going to explain you about introduction of polar coordinates, polar curves, polar coordinates, relation between Cartesian coordinates x and y, and the polar curves r, theta. Applications of polar coordinates. These are the topics today I am going to explain you. First, the introduction of polar curves. Another important system of the represent our point in a plane known as the polar curve. We are generally introduced to idea of graphing curves by relating x value to y value through the function f. That is, we set y of f of x and plot a lot of points pairing of x and x comma y. And the next is polar coordinates. Polar coordinates as a system is a coordination system in which the coordination of points in the plane are its distance from the fixed point and the distance from the fixed line. The fixed point is called as the origin or the pole, and the fixed line is called as the polar axis. The coordinates given in this way are called as polar coordinates. Initially, refer is chosen by the plotting of a point theta in the plane called as a pole. A line 0 to L drawn from through 0 is called an initial line if a P is an any given point in the plane joins to the point of O to P. With the result, an angle is formed at O. The length of the OP denoted by R is called radius vector of the point P, and the angle LOP denoted by the O theta measured in the anticlockwise direction is called the vectoral angle. The pair r and theta represented by p is equal to r comma theta or p is equal to r comma theta are called as a polar coordinates of a point P. It is evident that r is positive and the theta lays between the two planes according to as the position of theta from the point P in form coordinates. We now proceed to establish the relation between the Cartesian coordinates x comma y and the polar coordination r comma theta. Relation between Cartesian and polar coordinates. Let x0 xo x dash and yo y dash be a set of rectangular Cartesian axes of polar coordination through the origin O. Now consider a polar coordination system those whose poles are initial line congruent respectively with the origin P and the positive axis x-axis of the Cartesian system. Let theta be the any point of the plane whose Cartesian and pole consider are x comma y and r comma theta represently. Drawn PM perpendicular to OX, then we have OM is equal to X, PM is equal to Y, OP is equal to R, MOP is equal to theta. From the right angle triangle MOP we get X divided by R is equal to cos theta, or x is equal to r is equal to cos theta is the equation 1, and y divided by r is equal to sin theta, or y is equal to r sin is equation 2. Using equation 1 and 2, we find that Cartesian coordinate x comma y of point those whose polar coordinates r comma theta are given. Again, from the right angle triangle OPM, we get r square is equal to x square plus y square, or r is equal to root x square plus y square is equation 3, and tan theta is equal to y comma r, or theta is equal to tan minus 1 y comma x is equation 4. Using equation 3 and 4, we can find the polar coordinate r is equal to theta of the point whose Cartesian coordinates x comma y are given. These are the theorem of relation between a Cartesian and polar coordinates. And the next is applications of polar coordinates. There are only two types, velocity and acceleration in polar coordinates. First is velocity. The velocity of a particle in polar coordinates can be described by its radical and tangential components. The radical component of velocity is given by the time deriving of the radial coordinate. Vr is equal to dr by dt. And next is acceleration. The acceleration of the particle in the polar curve can be also described by its radical and tangential components. The radical components are acceleration is given by the time deriving the radial component of the velocity. AR is equal to dVr divided by d theta. I hope you all guys are enjoyed my video and understand it as well as if you guys gain some knowledge, please go and subscribe my channel and please like this video, and thank you for everyone.